Hello, I'd like to talk about TTyped for a moment. This is a language I worked on about a year ago. As it says, it's a dependently typed language based on the calculus of constructions. My main goal with this language was, just for learning purposes, to learn how a dependently typed language is implemented. Also, at the time, there weren't that many simple dependently typed languages, and most of the ones I could find were either fairly complicated or they were inconsistent. It was possible to write types that proved false. So they weren't really useful as a logical system. So this is the GitHub site for TTyped. I'll put a link in the description below. For now, let's jump into REPL. So first off, probably the most basic construct you have in TTyped is a function. So to start off, we write backslash, which is how we represent a lambda, kind of like in Haskell, followed by a variable name, colon, and then the type of the variable. As in the original calculus of constructions, a star corresponds to the type of all types, and then we put a dot and then the return expression, which here we're just returning x. Once in the REPL, it'll output the pre-printed value. In this case, we have a lambda x colon star dot x, and the type, which is for all x of type star, we return something of type star. So also note that star itself does not have a type. So since we're in the calculus of constructions, we don't have type universes. So we don't have type 0, type 1, type 2, so on. We only have the types of types, which itself does not have a type. There's also several things you can do with this. We can, for example, write the identity function, which takes a type and returns a function that takes the value of that type and returns that value. So this is the identity function. And we can also bind functions to names with this syntax, let wherever equal some function. And so now I can refer to it as ID. And we can also bind names to types. So this is the identity functions type, and it equals at x colon or a colon star at x colon a. So we take something type star, and then we take the value of type x, of type A, and return something of type A. So now we can write, for example, ID t, ID. So ID takes a type, namely its own type, and itself is an argument, and returns itself. So that's pretty simple. Also note that Unicode works just as well as ASCII. But I don't imagine many people would use the Unicode just because it's hard to type out unless you have a Greek keyboard. And even then the formal would be difficult. So we also have some syntactic sugar. So for example, we could say that A be a type and B be some type, and then we take X of type A, and then we ignore the second argument of type B and return X. So this would be the constant function, or const in Haskell. So by writing an underscore, we simply ignore an argument. And this also gets to the second piece of syntactic sugar, which is if we ignore an argument in a function type, we can just write the left-hand type, arrow right-hand type, instead of having to, like, say, write. So instead of having to write at A star at B star instead of having to write something like this, we can just write something like this. Yeah, they're basically the same. In fact, we can even simplify that a bit and write A to B to A. And they'd, the grouping is how you would expect. So, yeah, they're grouped the same as you would expect, such in as in Haskell or what have you. So that's basically all of T-type syntax. The semantics are as described in Coquelin's original paper, which is referenced on in the repository. So if you go down to let's see, where is it? Semantics. Yeah, the calculus of constructions by Coquelin and Hewitt. It basically follows those semantics exactly, except for the bindingness, the let bindings, but besides that, it's pretty much the same. So in addition to the REPL, we also have a set of libraries. So probably the most used would be the base library, which contains like the definitions you'd expect, like the identity function, the constant function, function composition, bottom type, the negation type, unit type, booleans, the dependent sum type, dependent product type, or sigma type, and then the identity type for equality. What's interesting here is how identity is encoded. It's basically saying that if two values are equal, so x and y are equal, then any proposition on their types, for any proposition about their the values, if that proposition holds for x, then it must also hold for y. And from that we can deduce reflexivity, symmetry, transit, you know what I mean, and congruence. We also have to define that type for types, since, you know, we can't pass star in for type A because star is not of type star. So we have to have a separate data type for that. And then we also have natural numbers, church encoded as you'd expect. Contains all the basic operations: addition, multiplication, powers, predicates, subtraction, comparison, and even division, remainders, and factorial. It also has a proof that if any numbers n and m are equal, then their successors are also equal. We also have lists, but another interesting library, more interesting than lists, would be the proof library. Currently it only has 2 proofs in it, basically proving that the negation of a for all statement is the same as an exist statement. So universal quantification is the negation of an existential statement, and vice versa. So to load the library in, you just give as an argument, and then we can use all of those functions and types that are defined in it. Anyway, that's TTyped in a nutshell. It's a pretty interesting language, very minimal dependently typed language. The source code itself is around 400 lines long, of just code, and then several hundred more like lines or comment lines, whatever. However, the main reduction engine and type checking engine is only about 120 lines long, up to 130. So, if you want to look at a small, dependently typed language that you can learn from and easily read its implementation, then TTyped might be for you. It might be interesting to check out. And of course, if you find any problems with it, open up an issue. If you want to make any changes or have any changes to contribute, open up a pull request. Contributions are always welcome. And besides that, thanks for watching. Hope you enjoyed, and hope you try out TTyped.